All right, this will be an 8th grade video lesson for page 98 in your book. There's only 6 questions. We will do all of these. In the last chapter, chapter 3, we talked about proportional relationships. Proportional relationships were always in the form y equals kx, and they always went through the origin. In this lesson, we're going to talk about non-proportional. Non-proportional relationships. These are in the form y equals mx plus b. Now we've seen this letter M. Letter M represents slope, represents the steepness. So a higher value for M in front of the x. Same thing with K, by the way, they are the same thing. A higher value would be a really steep line, but a low value, like a fraction, would be maybe like this. So this would be like a half, but this one would be like 6. So we figure out M the exact same way we figured it out in section 3-2, where we're going to calculate the rise over the run. So like in this line over here on number 4, we would find out, it goes up 2 over 1, up 2 over 1. Okay, it's the exact same thing. We've done it before. The only thing that's different is now our line is not going through the origin. Instead of the origin, we're going to go through the point B on the y-axis. So we look at our y-axis, and B on this line is 2, because on number 4 we can see that our line, our blue line, goes through on the y-axis at 2. So I'll go ahead and clear all of these words out. For this section and for the next section, we're just going to work with non-proportional relationships. So let's see what they want us to do on number 1 here. Make a table of values for the equation. So we have the equation y equals 2x plus 5. And to just talk about this, we have a slope of 2, so this line is going to go up 2 over 1. So it'll be like that. Up 2 over 1, up 2 over 1, up 2 over 1, all the way. And our y-intercept is going to be at 5. So if this is our y, this point right here is at 5. So that's what this line is going to look like as a graph, but not exactly what it's asking us here. So we need to make a table of values, and they got to start it for us already. X and Y, and they say -2, -1, 0, 1, 2. And now what we're going to do is we're going to take these values for X, and we're just going to plug them in for X. We'll do it 5 times. So the first one is 2 times -2 plus 5. And then we'll just do order of operations. 2 times 2 is 4. 2 times -2 is -4 plus 5. Thinking about this maybe on a number line, we're starting at -4. We're going to go up 5. 1, 2, 3, 4, 5. So here's -3, -2, -1, 0, and 1. That is 1. Next, we're going to do 2 times, well, I'll use parentheses as multiplication because I have negatives here. -1 plus 5. 2 times -1 is -2 plus 5. So now we're thinking of this number line we've got a minute ago. We're going to go up 5 from -2. 1, 2, 3, 4, 5, which will put us at 3. So that's 3. Okay, next we're going to do 2 times 0 plus 5. Well, 2 times 0, we like that one. That's 0 plus 5 equals 5. And you should see a pattern starting to form here. If we have a pattern in our x, see we're going up by 1 every time, all of our linear equations should form a pattern in the y as well. So let's see if we get 7 on this one. We've got 2 times 1 plus 5 equals 2 plus 5 equals 7. And the last one, 2 times 2 plus 5, well, that's 4 plus 5, 9. So we do have a pattern that goes here. We're doing plus 2, plus 2, plus 2, plus 2, which makes sense, especially when we think about our slope that I mentioned earlier. I showed you it was going to go up 2 over 1 every time, up 2 over 1, up 2 over 1. We notice this goes up 2, up 2, up 2. The y value does go up by 2 every time. And the x value goes up 1, up 1, up 1, up 1. That is a pattern that does work. That is, when we find our slope, this shows us that every time we go up 1 in our x's, our y's goes up 2. So we'll fill this in, try and make it as neat as possible for you. So if -2 is x, y is 1, 3, 5, 7, 9. All right, go ahead and move on to the next one. Next one is a fraction, y equals 3/8 x plus 5. And notice their table of values, they started with -8, 0, 8 for our x and our y. And they gave us a couple of empty spots. And I want to talk about what that meant from the last one. Every time our x goes up by, well, I don't need to talk about that right now. We'll make that conclusion later. I don't think it'll make any sense right now. So let's see. 3/8 x plus 5. I'll do the first one over here. We've got 3/8 times, and I'm going to write -8 over 1 instead of -8 because we're multiplying fractions. We got to make sure we have a denominator in order to multiply these straight across. So let's see. If I'm going to multiply fractions, I've got 3/8 times -8 wholes. You may remember last year, and this only works with multiplying fractions. If we have an 8 and an 8 in our numerators, essentially what we're going to do is the commutative property, where we're just going to switch our numerators. This is going to be the same thing as -8 over 8 times 3 over 1. And -8 over 8 simplifies to -1 because that's -8 wholes. Think of it, maybe move this negative down here. It's -8 over 8. Well, that's -1 times 3 is -3. So that one equals -3. And then we'll do 0. So we've got 3/8 times 0 plus 5. Well, 3/8 anything times 0 is 0. So there's our 5. Next, we've got 8. So we'll see 3/8 times 8 over 1 and then plus 5. I'm going to do the same thing where I use my diagonal 8s and I simplify that to the number 1. So then I have, well, that's just 3 plus 5 equals 8. So that's 8. Next, we'll do, well, let's follow our pattern. From here to here, we're going plus 8 in the x's. From here to here, we're going plus 8. Let's keep going plus 8. And the reason they're doing this by 8s is because our denominator is 8ths. And if we go up by 8s over and over again, by 8s in the x, we'll find out that our y value is a whole number or an integer instead of a fraction, because 3/8 is our slope. But if we keep going up by 8 at a time, we will be moving up by 3 at a time in the y. So let's see if that pattern continues, because here I go, oh, I think I got a mistake. 0, -8. I think I got to fix this one right here. I think I had a negative that I wasn't supposed to have. So let's go back and check that one. We've got 3/8 times negative 8 over 1 plus 5. Yeah, that was our mistake. So that's going to be our 1. That's going to be our 1. I've got negative 3 plus 5. I forgot to do this plus 5 a minute ago. So negative 3 plus 5 does not make negative 3. It makes 2. So I went ahead and fixed that right there. Make sure you fix that if you're following along. Even I make mistakes here and there. It happens as long as we fix them. So now we're going to do this with 16. So we have 3 8 times 16 wholes. Then we'll do plus 5. Make sure I do that this time. 16 and 8, we can reduce these to 2 and 1. We can divide them both by 8. So I have 6 plus 5, going to give us 11. Which then, 24, I can see I'm going plus 3. I'm going here, I'm going plus 3. From here to here, I'm going plus 3. As long as I keep the pattern in the x's, plus 8, my pattern is going to remain the same here. So 11 plus 3 is 14. And then we see this slope value. The slope, again, we have our y over our x. Every time our y goes up by 3, our x is going up by 8. And we can see that. Here's by 8, here's plus 3, here's plus 8, here's plus 3. So we'll fill that in. 16, 24, 14, 11, 8, 5, 2. All right. One. We need to explain why each relationship is not proportional. So remember proportional. Proportional has, it's a line that goes through the origin. We need to look at these and decide, is that true with these? Also proportional, the value for y over x is always constant. That was our k. We figured out k is a y over an x. Well, let's see if that's the same here. I'm going to start on this 2 to 7. That's times 3.5. Okay. But let's see what 3.5 times 4 is for that next one. 5 times 4 is 20. 3 times 4 is 12, 13, 14. And make sure I move my decimal over because I go 1 time, so I go 1 time. Well, this number right here is 11, not 14. So I can already see, it says first calculate y over x for the values. In any proportional relationship, y over x is constant. Okay, all the time. If it's proportional, it's constant. It's the exact same. In this case, it's not. So they first wanted us to calculate this. So I'm going to go ahead and just say right now, y over x is not constant in the table. I next want to talk about this point 0, 3. Okay, it says x, y, 0, and 3. This is a point 0, 3. It's our point x, y. Okay. Well, I can tell you if our line goes through 0, 3, it's not going through the origin. So that's another explanation. So let's go ahead and add that too. It also does not cross the origin, right? It doesn't cross the origin. It goes through 3 instead on the y-axis. So we've got 2 reasons why this is not proportional. Look at the next one. We can just choose one of those reasons from the previous problem. We've got, let's see, we've got a line. I talked about it earlier. It does have a constant slope, but its y over x isn't going to be exactly the same for every point because this does not cross through the origin. So let's just go ahead and phrase that some way. We'll say the line does not cross the origin. And I think that covers it just good enough. That's why it's not proportional. All proportional relationships go through 0, 0. Well, this line doesn't, so it's not proportional. Number 5, complete the table, then graph it. So let's see. We've got y equals x minus 1. And our table of values, we start -2, -1, 0, 1, 2. So let's do -2. Grab a different color. Y equals -2 minus 1. Well, those are both negative, so I'm starting at -2. I'm going to go one lower to -3. Y equals -1 minus 1. Well, that'll be -2. Y equals 0 minus 1. Well, 0. So that'll be -1. Y equals 1 minus 1. That's 0. Y equals 2 minus 1. That's 1. So what I did was all 5 of these just really quickly. If it's just -1, I can pretty well do those quickly because I know that 2 minus 1 is 1. 1 minus 1 is 0. 0 minus 1 is -1. Follow this pattern, -2, -3. Now we need to graph these points. So this point right here, this is -2, -3. This is one of our x, y pairs. So our x is going to be a -2. So here's our x-axis, and here's our y. So if we're going to -2 in the x, we got to go to -3 in the y, and we'll have a point right here. Next we have -1, -2. So we got a point right here. 0, -1, 1, 0, and 2, 1. And then once we have all 5 of those points, we can now connect those points with a line that looks nice and neat. And then make sure you have arrowheads, because we could say x equals 100. Well, then y is going to be 99. So that's still going to be on our line. So we make sure we put these arrowheads so it goes forever. All right. For number 6, I want to give an example of like what a non-proportional relationship could mean. So let's see. I'm just going to make one up right now. I started with 3 cats and got a new one each year. All right. So I want to use this problem I just made up to write a proportional relationship. So, a non-proportional. So if my x is going to be years, my y is going to be cats. So in the 0th year, how many cats did I have? Right at the start of the story, well, I had 3 cats. After 1 year, how many cats? Well, I'll have 4 because I gained 1. After 2 years, I'll have 5 cats. After 3 years, I'll have 6 cats. So now we're going to look at this. So I started with 3 cats. So let's talk about y equals mx plus b. Okay. Our x goes up by 1, goes up by 1, goes up by 1. Our y goes up by 1, y goes up by 1, y goes up by 1. So slope is our rise over run. And it's going to be 1 over 1 because our y goes up. I'll write it up this y over x. And it's not y over x. It's not 3 over 0. It's the y change over the x change. And the y change, we're going up by 1s at a time. And the x change is 1 at a time. So that'll be 1. B is always the starting value. So we started with, in this one, 3. So I have the equation y equals x plus 3. And if you wanted that 1 in there for x, that works. We're starting at 3, and we're going up 1 cat every year. So for number 6, it says, how can you choose values for x when making a table of values representing a real-world situation? So values of x for years. I want to talk about why I did 1, 2, 3, and why I didn't do 1/2, 3.5. For a problem like this, I want to know if it makes sense. If I do a half, does it make sense that I have 3.5 cats. Oh, kind of silly, right? If I started with 3 cats though, and it takes a year for me to get a cat, it doesn't really make sense that I get a half of a cat halfway through the year. It's not like this cat just starts at the tail and every day gets one fraction more of a cat every day. It really just doesn't make any sense. So when we're choosing values for x, how do we choose the values that we should use for x in a real world situation? Well, what we have to do is we have to decide what actually makes sense. We maybe think about, well, if we're talking about money, well, I can actually have 2 decimal points. I can, if I'm doing money in the x value, so if my money is x, I could do 1.56 maybe, because dollars and cents does usually go 2 decimal places. If I'm talking years and I'm getting a cat every year, it doesn't really make sense to use half of a year. So I think a good enough explanation is just we need to decide what makes sense best for our variables. Because it depends on the word problem, really. If I run 5 miles an hour, I could say how far I've gone after a half of an hour. So in that case, like the half could work. After a half an hour, I've gone 2.5 miles. But in this problem, half doesn't exactly make sense. You end up with you start with the tail of the cat, right? So after a half of a year, I have this much cat. Doesn't really work, right? So then like a month later, my cat looks like this. And then after a month later, my cat looks like this. A month later, maybe it gets another leg, right? And then, it just doesn't make any sense. So we just got to make sure our variables make sense. So to summarize, we have y equals mx plus b as our equation form for non-proportional relationships. So it's y equals mx plus b. B is the starting value. And you're going to see the word initial value. That's just the starting. And m is our slope. It's our y change divided by our x change. It's also rise over run. In the next section, we're going to be writing equations based on graphs. So see you then.